In this problem, we have a mineral that consists of calcium carbonate, and the chemical formula for calcium carbonate is CaCO3. The atmosphere of this hypothetical planet consists of methane, which is CH4, and carbon dioxide, which is CO2. It has an ocean that is 25 fathoms, and we want to convert that to meters, given that we know that 1 fathom is 6 feet. And we also know from our conversion factor sheet that 3.28 feet is equal to 1 meter. So we're going to start off with what's given. And we're going to go from fathoms to feet to meters. So we start off with 25 fathoms. And we know that for every 1 fathom, it is 6 feet. And for every 3.28 feet, it's equivalent to 1 meter. And we're going to report our answer to 3 significant figures because 1 meter is 3.28 feet, and that's an English to metric conversion. Our feet cancel out, fathoms cancel out, and our answer reported through 3 significant figures is 4.44 times 10 to the third meters. In the next problem, we have a square piece of aluminum foil that is 4 inches on one side. It weighs 0.466 grams. We want to determine the thickness of the foil in millimeters, given that we have the density in centigrams per centimeters cubed. So let's first go ahead and draw a square piece of the aluminum foil. And since it's a square, each side is 4 inches. But we have to take into account the density of the mass to determine our thickness, which we'll label T. And because this is a square, we know that the area of a square will be your side squares. So we'll say it's T squared. And we know that density is equal to mass over volume. And we can determine the thickness of the foil by the following formula. Thickness can be determined by taking the volume of the aluminum foil and dividing it by the area of the aluminum square piece. So we need to determine the volume of the aluminum foil and the area of the square piece. We can determine the volume by using density and the area using our equation for the squares. So our first step is to determine the area of the square piece. And that's just going to be one of your sides squared, because we said area is equal to T squared, so that will be 4 inches squared, and so that will be 16 inches squared. The second step is to determine the volume using the density. Okay, but if we look ahead, we should get our volume in similar units as to the area. So we want to determine that volume in inches cubed. So let's go ahead and get our density and convert it to grams per centimeters cubed to prepare for converting it to inches cubed later on. So we have our density, which is 269 centigrams per centimeters cube. And we know that in 1 centigram, there's 10 to the negative 2 grams. So in grams per centimeter cube, our density ends up being 2.69 grams per centimeter cube. Now we're going to use that to determine our volume. We first start off with mass, which is 0.466 grams. And then we use our densities to get to centimeters cubed. We know that there's 2.69 grams per 1 centimeter cube. And we know that there's 2.54 centimeters per 1 inch. But we have to cube this conversion factor so we can cancel out our centimeters cubed. And so when you plug this in your calculator, we're left with 1.057 times 10 to the negative 2 inches cubed. And this is going to be your volume. Okay, so we have our area, which has 2 significant figures. And we have our density and our mass, which has 3 significant figures. So we'll put a line underneath the 5 to indicate we're going to stop at 3 significant figures. And now our last step is to determine the thickness by taking our volume divided by the area. So we're going to take 1.057 times 10 to the negative 2 inches cubed and divide it by 16 inches squared. And so if we calculate that, that will be 6.606 times 10 to the negative 4 inches. Because when we take inches cubed divided by inches squared, we're left with inches. And I'm going to put a line underneath the 6 to indicate we're going to stop at the 6 for 2 significant figures. And actually the last step is to convert inches to millimeters. So we start off with our answer from 3. We have 6.606 times 10 to the negative 4 inches. We know that there's 1 inch has 2.54 centimeters. And we know that in 1 centimeter, there's 10 to the negative 2 meters. And there's 10 to the negative 3 meters in 1 millimeter. And so that will gives us 1.7 times 10 to the negative 2 millimeters as the thickness of your aluminum foil.